We are super lucky to be here today. This is part of a VADA speaking series called VADA Talks, which is also being given out in our communities. So we're really, really lucky to have these professionals here today presenting to you, the students. We're speaking about AI and quantum computers. It's a little intimidating, but I think we're going to learn a lot today. Okay, here's Ellie. Thank you.
Hello and welcome everybody to our VADA 2024 Art Design and Quantum Mechanics. I'm Ellie Cuevas. I'm your VADA 2024 co-president, and I will be introducing them. So this gentleman right here is Les Feirenstein. He is the founder and editor of the magazine The Riv. And then we have Eric Lucero, the site lead and engineer on campus and co-founder of the Artist in Residence program. Then we have Forrest Stearns, the principal artist at Google's Quantum Computing Lab and co-founder of the Artist in Residence program. And then finally, we have Robin Donaldson, the architect for the quantum computing facility. And I'll pass it on to Les.
Thanks a lot. Thanks all of you for coming out. First of all, I just want to mention that there's this epic project that's going on. That's what we're all talking about today. And it's happening, it's kind of going to change the world, and it's happening out in Goleta. So good stuff can happen here. I'm going to introduce all these guys in a moment. But first, I just wanted to tell you why I'm here and how I got involved with these people in the first place. So I founded this magazine called The Riv. Do any of you read magazines? Not really, right? Okay. So yeah, there used to be a thing called publishing, and in publishing, we had magazines. And in Montecito, where people are much older than you are, we still have magazines. So I decided to start a magazine at this late date in our empire. And for our premiere issue 2 years ago, we're incredibly lucky to feature an amazing Earthship-looking project. It was a house called the Hill House, which was designed by this gentleman over here, Robin Donaldson, and his client, someone named Bruce Even. It was an incredibly ambitious, complex project, somehow got done. And I think the program, that's what they call it in architecture, like, well, what do you want this house to be? Robin's client said, I want it to be like a James Bond villain's lair. Because I guess there's a connection between high design and, I guess, evil. So the Hill House, this incredible structure that was created by Robin and Bruce, that became our cover story. And we did a 30-page article about it, and the design world loved it. Our online data showed that while most people flip through a magazine just for a couple of seconds a page, people engaged with this article for a half hour. So it was kind of an epic story, and it immediately put our magazine on the map. And because it was such an epic story, it also created kind of the possibility that our second issue wouldn't be as good, that we'd have a sophomore jinx, and that basically we would suck. So I asked myself the question, how could we possibly top that first issue? So of course I went back to Robin Donaldson and I said, hey, what else you got? What other projects you have in the oven? And he said to me, kind of cryptically or mystically, he said, you know, I'm working on this thing out in Goleta with Google, and I'm not sure I completely understand it, though I understand the architecture of it. And let me see if I can get them to talk to you. So basically, I had to be vetted. I had to be approved by Google. They probably looked at my search engine or something. And eventually I was told that, yes, I could meet with Dr. Eric Lucero, the head of this program. So I went out to Goleta to see what they had going on out there. And the project was, in fact, mind-blowing. So when you get out there, first of all, there's kind of like a Jedi mind trick going on, which is like you're standing in front of this building, but somehow you can't really see it. And there's not like a lot of marking on it and stuff. there's like a tiny little sign. I think it's like 4 inches big that says Google AI, something like that. But what was interesting once I got inside was not just what they were doing, which is essentially building a computer in a very different way that I believe will be the world's most powerful computer, or that's the goal, one of the stated goals. But it was also how they were doing it. They were creating this kind of cathedral of creativity out there. And all of this happened before ChatGPT came out. And so AI wasn't really so much on people's minds, and the mainstream press wasn't covering it, and people didn't really know what AI was about. So you tell me if I have this wrong, because I've heard that this supercomputer that they're building out there in a different way is going to be something like, what is the order of magnitude? Is it 1 billion times more robust than the current world's most powerful computer? So that's kind of a big deal. And, I think as we get into this talk, we'll talk a little bit about what that means. What could that computer do that a regular computer can't do? And one of the things that always caught my mind was, we're going to be talking about, among other things, post-encryption society. And what that kind of means is that the computer can run through so many combinations of things so quickly that it can break codes, any code, most codes, as we know them today. So we're going to talk today not so much about artificial intelligence and quantum computing. Obviously, we'll be doing some of that, but really just about thinking creatively. We're going to talk about this epic collaboration between these artists and scientists that has made Google the front runner in the race for what they call quantum supremacy. And it's also made the Google workplace, because it's so cool, Google's highest attended place of work. In a nutshell, people really like being there, and I think they're inspired to be there. So the quantum computer is going to do great things, and I think, like everything else, it'll eventually do things that are not great, because that's the nature of, I think, all things. But before Google could even build this machine, first they had to create this incubator for inspiration, so that these people could all create and collaborate and freestyle and bounce stuff off each other and collide with each other and be silly and make mistakes and hopefully take humanity to the next good place. So I'm going to introduce you now to this team. Okay, so the first person I want to talk about is the architect, Robin Donaldson, who was the first person I've known of these people. He is the founding partner in 1991 of Shubin Donaldson Architect, which is a 40 architect firm with offices in LA and Santa Barbara. Prior to that, he worked at Morphosis Architects, which was, I think, founded and run by Tom Main and Mike Rotundi. So Tom Main is essentially the equivalent of a Nobel Prize winner for architecture. While working at Morphosis, Robin completed his master's in architecture at Southern California Institute of Architecture, known as SCI-Arc. He graduated from UCSB in 1981 after studying studio art and architectural history and theory with a very famous dude out there named Dr. David Gebhardt. Robin grew up in Southern California. He's a fourth generation Californian. He's been living in Santa Barbara since 1988. Prior to that, he was in LA and Europe. He's married to someone named Aaron, and he's the father of 2 sons. His older son is studying architecture also at SCI-Arc, and his younger son, Payne, he's studying naval architecture and marine engineering at Webb Institute in New York. So a bunch of architects came out of you as well. And I want to mention that Shubin Donaldson Architects is extensively published. They've done a bunch of books, and they get cited in famous architecture magazines and publications all the time. And they've won a ton of awards. as you might expect. So, ladies and gentlemen, Robin Donaldson.
Hi guys, good to be back on campus. So when I was 8 years old, I broke my arm at an oil painting lesson. And since we're talking to a VADA class today and talking to a lot of other students, I wanted to talk a little bit about the path that I took that ended up working with Eric and with Forrest and eventually even Les. And it all started with the fact that I could draw and I could paint. And when I was a little kid, my mom said, let's get you to an oil painting lesson. Do you want to go? And I went, and I spent more time screwing around, and I broke my arm. But I did manage to get this painting done. Many years later, this is my office today. And I kind of wanted to show you guys this to get a sense of what an architect's office could look like. A lot of us think it's a lot of people lined up in front of computers. We have that, but more importantly, we have creative spaces where we work a lot with materials and how materials are made, fabricated, and in what form and why. We have tools to do this. I have my own shop. I have my own 3D printing machines. I have all the tools that we need to envision, to learn how to design, to test different kinds of materials. And I wanted you guys to see this, to be aware of the fact that there's a lot of paths you can go in if you start thinking about, if you're interested in the art side, drawing, making things, using your hands, thinking, all of these things. There's environments for this. This is the house that Les was just talking about that he had in the Riv magazine. And this, of course, is a drone shot looking down on top of the house. The house is completely covered in earth, and it's almost invisible. So most houses, when you drive by them, of course, you see a box basically sitting on land. I'm interested in this notion of a relationship between the earth and between architecture, where they're more equal. So you could drive by this house and you might think it was a hill, for instance. And making a house that looks like a hill raises a lot of questions, doesn't it? And I think that good architecture raises as many questions as it answers questions. And I think that's where architecture can start to get into the realm of art. Art essentially is asking questions and sometimes not always having the perfect answer, but because there may not be an answer, but communicating ways that aren't necessarily descriptive with words and sentences. So a deeper communication. And I think art and architecture can do both. That's actually an art installation inside the house. This is where the front door is. When you come to the front door, you're looking out at earth and the sky and the trees, and the form evokes natural kind of forms and elements. Similar shot looking out. You see that curved form, that's actually the front door. So the house does have a front door. You go in the front door, and as you come into the house, you create a new world that is a combination of house and art gallery to some extent. We worked with artists on creating artistic constructions and sculptures and things like that that are inside the house. That's another view of the courtyard. In Santa Barbara, there's a tradition of houses having courtyards. This house has a courtyard, just looks a little different than most courtyards. That's a sculpture by an artist that we worked with. He designed that specifically for that space. People always ask, what does this look like inside? And there it is, that's what it looks like. That's the living room. Next slide. We have elements that let light down into the house. So these are basically skylit shafts that let light into the house. Light, the earth, material, those are the basic elements of my architecture. And eventually, these start to translate into the Google Quantum project you're going to see in a sec. Here we are. So you've heard Les talk about Dr. Eric Lucero and his project that he works with Google to create this amazing computer technology, quantum computing. This is what you see when you come in the front door. And you might notice there's some artistic elements there. There's patterns, there's lines, there's drawings, there's things like that. All of those are all referential to the actual program, the computer program. It's almost like a language. And oh, by the way, they have fun and they do things physically. It's very important, this balance between physical and creative side of what the physicists do. That's a climbing wall. This is the space where the actual quantum computers reside. And you see the murals on the wall. These were created by Forrest and his team. This is where you start to get a sense of that integration between the science and the art. We just wanted to touch on some of the forms and where they came from. We work a lot with natural forms. These are all studies that were done in preparation for the project. Essentially, Eric is dealing with, in a sense, a subatomic form, sense. I mean, that's how I understand it, right? You're understanding how these particles behave and so on, and you have to use art, essentially charts, graphs, lines, to communicate those, not just words. So all of this eventually ended up being incorporated into the project at a later date, and like for instance on the walls and things like that. A lot of these things you guys probably recognize if you've been to the beach or you've obviously been on a hike. And I could let Eric talk about some of these forms and where they're coming from. And I think we're up with Forrest. Thanks for listening, guys.
So that's not a house you see every day, right? By the way, the house that he showed you, the Hill House, when it was being built, I thought it looked like a skateboard park. And our original plan was to get a bunch of like world-class skateboarders out there, which I think Robin was down with, but the owner was not. Anyway, let's get over to Forrest here, whom I refer to as Google AI's Chief Magic Officer. Forrest Stearns, some of these are his words. That Forrest Stearns has a passion for the illuminated artistic practice of illustration, using bold drawing to help tell stories and promote adventurous ideas. He is an academically trained illustrator, an arts educator, creative facilitator, and community builder. Most importantly, he is a passionate father and supportive partner. So I'm taking you at your word that you're a supportive partner. This passion for drawing is amplified in artist in residence programs that connect artists, scientists, and technologists. He is the principal artist at Draw Everywhere Studios, where he produces unique artworks and leads collaborations connecting artists and institutions. Currently, he is the creative innovation consultant and artist in residence co-founder at Google AI Quantum in Santa Barbara. From art galleries, this is true what I'm saying here, from art galleries to spaceships, there's nothing Forrest won't draw on. His artistic portfolio radically spans media and substrate, from endless sketchbooks of organic characters, laser-etched drawings covering hundreds of satellites that orbit the Earth. So you get that his art is orbiting the Earth right now, along with Elon's Tesla. He does art on quantum computers and giant murals on surfaces ranging from buildings, radomes. What are radomes? Well, you'll tell us in a second. And he does, as I said, he does art on rocket ships. And I just want to add this other part that I'm not sure that you wanted me to say, but it's worth saying. So the Google AI Quantum Artist in Residence program was founded 5 years ago by Forrest and Eric. The mission of the program is to bring creative permission to the quantum team through the production of large, thought-provoking art, as well as facilitating team-building events. Innovation is enabled when teams are supported in creative exploration and conversation. I think that's all important. So I'm going to kick it over to you, Forrest.
I'm going to stand up. Hey, thank you, Santa Barbara High School, for being here. Thank you, VADA, for representing. And I think it's really important to just recognize that we're all here together. And he's going to keep me from walking off the stage like my Voltron units here. So it's important to know that as professionals, we're standing on the stage with years of experience and practice. But it's really important to know that many of us are superheroes in disguise, right? I may show up as a professional and be able to speak professionals, but I also have a humble beginning of being a street artist. I always had one foot in the fine art world and trying to get educated, and one foot in the graffiti world of trying to also have fun with art. So notice that we are totally in disguise and that we're out on a mission. My name is Forrest Stearns. I have an MFA, but I don't think you need to get an MFA. You can call me he, him, and I am a hip hop artist and part time superhero. So, as a superhero sometimes does, I had a kid, my partner and I had a child, but I still maintain my creative practice. It's really crucial to always be practicing, to always be building your community, always trying to be work together. We're building ropes as individuals. We're becoming strong ropes, and those twines of ropes are our skills that we bring in, and our ropes together make knots that make us really strong. Got Ondo Pendilian in the room right here, looking like a high school student. I love it. Where's Waldo? So Ondo's here. Ondo's been a dear partner of mine in the arts for a decade, and we have done a lot of great work together. Ondo probably took this photo. So representing the opportunity to go to places where you wouldn't normally get permission to go. Put art on things you wouldn't normally get to put permission on by asking permission. We're at a venture capitalist campout, drawing nature and representing the arts with the world's entrepreneurs, strongest entrepreneurs in the world. Here's my title slide. I love to draw people, and we'll see that this is probably the most professional slide on here. So showing up and drawing everywhere has always been my thing. I love to draw. I keep a sketchbook with me always behind my belt, and being willing to take hundreds of little sketches and make them into big pieces makes people stand around you and go, wow, what is this? And all it is practice, you know, and all of us have that power. I'm sure all of you have a sketchbook. So where that last slide was creating a drawing for a sustainable lunar settlement with a bunch of people who can sponsor that kind of thing. I went to high school, like all of you. I was halfway in and halfway out of high school, really being excited about creativity, and that's what drove me. Then I took 10 years and practiced, empirically getting educated in and out of college, doing a lot of adventures, and then I finally figured out that going to grad school was a good thing. So, like Les said, I randomly figured out how to make the first art show in space by doing big work, by showing up, by drawing hundreds of drawings. This is really what it's about. This is my superpower as an artist, is filling 100 sketchbooks in 10 years. 100 of these of just getting ideas out. If you don't want to go to graduate school, I'll give you the $80,000 lesson right now. Write down every creative idea you have and then stand on your own shoulders. Stand on your own genius as you grow, as you accept new information into your brain, as you learn from other great people, your peers. Write that stuff down so you can have your genius in your book to stand on anytime. The reason why I'm on this stage isn't because I'm the best artist, it's because I practice, and this is proof. So my work sometimes spans from small work. Sometimes I draw as small as designing computer chips with scientists, but quite often I get asked to do, hey, can you get in and make a new voice to this old space? We just saw Robin's gorgeous new Earthship house. This thing looks like it's going to launch into space. Quite often we get the opportunity to do the opposite. Can you come into an established place with a legacy, with a story, and can you remix that? So I love that challenge. I love standing on the shoulders of my own practice, of my peers' practice, of the common conversation, and saying yes and. I love a good remix. This is a situation where the California State Library came to me and said, hey, we've got this mural on the wall. It's 100 years old, it's gorgeous, but it doesn't represent California now. What can you say to it that represents us now? So during the height of COVID, I'm walking back and forth through Oakland, listening to conversations, talking to people. And this became the California remix of what's happening in California today. You'll notice that there's a lot of drawing on this piece. I call that the mycelium of my style. I love to draw. It's the caveat of what I do. So I'm always putting drawings behind everything and in everything. It's the connector. like all of us, we're connecting with each other, we're building networks, we're building community, and you need to stand on that as you move forward. I took that love of drawing on everything and that love of being that guy who just asked permission. And I said, I met a guy at a venture capitalist camp out in the woods because I was representing the artist and said, hey man, can I paint on your spaceships? And instead of no, he said yes. So I didn't think he'd say yes, but then I had to step into my own skill and my own practice. And for 5 years, we put artwork on hundreds of spaceships. I love beautiful handwriting. So I used my handwriting that I learned with one leg in graffiti, one leg in hip hop, and I started writing beautifully on spaceships. I love nature. I grew up by Yosemite. I absolutely adore to illuminate nature. So the first art show in space was migratory animals looking back at Earth. And here's a whole lineup of the history of the spaceships that I helped build. Let's go to Vandenberg. So Vandenberg's right up the street. I got a call that said, hey, we are locally having a rocket ship launch where we're going to put a bunch of these spaceships in space. Can you do a painting that's going to go on the top of a rocket ship? Sure, of course you say yes to that. I didn't really know what that meant, but of course you say yes to this. And so in my studio, I painted a dove and a macaw. These are the two different birds that were representative of the satellites. You notice a gentleman pushing that rocket. You notice that was how you put a rocket up. Here we go. Here's the painting on a rocket ship. It's kind of surreal to see your own painting on a rocket ship. I'm not an aerospace engineer, but I love pushing the envelope. Here's what it looks like when those satellites go into space. So you'll notice that there's some handwriting on the side of the spaceship. There's some wiggly lines on the solar panels. And I also want to thank Ondo for laser etching these spaceships for me. We got together and we figured out how to put art on spaceships. You don't paint on a spaceship. You don't rock a Sharpie on there. You don't silk screen because that'll all degrade in space. So we're like, let's laser etch into these things. So thank you, Ondo, for being there for me. The first panel that ever got photographed by an astronaut in space was, of course, the one that says, hold on to your butts. A Samuel L. Jackson quote that, you know, why not be fun? Why not work with scientists, but also have a little bit of fun and joy in your workspace? So that was one where I thought I was going to lose my job, but I actually got a lot of people to laugh and got astronauts to even laugh about the fact that they took a picture of a spaceship that said, hold on to your butts. So here we are, day one, speaking the language of nature. I get a cold call when I'm working at this aerospace shop for 5 years. I had built an artist in residence program, really pushing creative permission, really pushing the culture of a technology company with the challenge of, hey, this is a sterile space that could be perceived as nefarious. We're putting cameras in the sky. And so I covered everything in artwork. I brought in an artist in residence program, 15 artists deep. And as the company grew from 25 people to 500, the art followed that common conversation. So Eric gave me a call and said, hey, I'm building quantum computers in Santa Barbara. And I said, hey, I lived in Santa Barbara 20 years ago. I know where that is. So he said, come down, and how about you do some art with us? All right, cool. You know, show up in my stupid outfit and just be really comfortable. So I showed up with 7 giant blank pieces of paper. And during an objectives and key results meeting, I painted the aviary, which is a hardware stack that runs a quantum computer that are all named after birds. Once again, celebrating nature. Once again, showing up with creative permission and just working. I love it. These aren't beautiful paintings at first, and a lot of the scientists came up to me and said, wow, I've never seen someone paint. This is amazing. I want to go try to paint. I want to go try to draw. And so here I am. The meeting is happening behind me. This is the Quantum Laboratories office. And so Eric liked what I did. I spoke to the team. I was giving a TED talk at the time, so I was really practicing that with the team. And he said, all right, I've got an architect on the line that's world class. He's amazing. Do you want to work with us? And do you want to be kind of the visual language of this space when we get it on day one? I said, of course, you know, you don't say no to that, right? You got to show up. He said, well, I'm going to need to see some sketches. So this is 16 sketches of what was hundreds of sketches just for one project. And we'll show you that project in a little bit. But goes to show that you can draw hundreds of pieces that you never need to show to anyone. That's the point. Practice in your book, make your mistakes behind closed doors ultimately, and then when you get the opportunity to go big, you're ready. This is the canvas. So this was a warehouse. We're all familiar with it. And you all might be familiar with this feeling, right? You say yes to a project and then you stand in front of a blank canvas and it's kind of overwhelming. You're like, wow, what am I going to do here? But with a lot of communication and a lot of focus and a lot of practice, we stood on the shoulders, and luckily we took a gross warehouse and made it into a temple of science. I liked the cathedral of creativity that Les said. All right, so you got to stay ready, because if you stay ready, you don't got to get ready. And when you're ready, you can always just show up. And when someone says, hey, can you do XYZ thing? You say as an artist, yes, I'd love to bring your valuable idea to life. Let's talk. You got to get empathetic. Use the design thinking method and really start solving problems. You really got to get in and draw through to get to your answers. Companies won't come to you because they love artwork. Companies will come to you because they have a challenge. And as artists, as multi-talented problem solvers, we can help solve those challenges for people. So I urge you all to go big, and thank you very much.
Thanks, Forrest. Look forward to hearing what the aliens have to say about all that stuff when they see it. Also, I agree with what you said about you should just be out there doing stuff. I'm a guy who went to film school. I went to 2 film schools. I went to NYU and to Columbia, and I wound up working in show business for like 25 years, and I never should have gone to film school. Those 2 years, I should have just been making film, making TV and stuff. So do stuff. That's a really good idea. So now let's introduce Dr. Eric Lucero. He is the lead quantum engineer and site lead at Google's Quantum AI campus in Santa Barbara. He has designed, built, and operates Google's Quantum AI campus with the mission, here's a mission for you, to build an error-corrected quantum computer for the world, so his client is the world, to enable humankind to solve problems that would otherwise be impossible. He is one of the scientists on the Google Quantum AI team who demonstrated humanity's first beyond classical computation, which is a very big deal and was written about in a very big deal magazine that was not the Riv. It was recognized as one of the breakthroughs of the year. He has 2 decades of experience in quantum architectures, controlling qubits, which maybe you'll discuss at Google, and a bunch of other important laboratories all over the United States. Eric has created also, because he's also an artist, a portfolio of photographs documenting the evolution of quantum processors from single qubit devices to Google's Sycamore quantum computer. In 2018, Dr. Lucero and Forrest Stearns, whom you just heard from, founded the Quantum AI Artist in Residence program to celebrate nature and build an inclusive and beautiful future through art and science. Dr. Lucero engineers quantum systems from the qubit scale to the campus scale and is building a community of all quantum mechanics. And on a personal note, I'd just like to say that often you meet people who have jobs like Eric's, not that there necessarily is one. I'm saying like someone like Mark Zuckerberg, I'm always waiting for his faceplate to fall off and you see all the circuitry underneath. But I think like with Eric, there's just a great humanity, and this is the kind of person you want to see in charge of such an important program that's going to have such a profound impact upon the world. So take it away, Eric.
Wow. Thanks, Les, for that introduction. I wish I could hand deliver that introduction to my younger self here, DJing in high school. Yeah, I think I would have really loved to hear that. Thank you. This is kind of a lovely beginning of kind of where you all were. When I was in high school, I was really excited about hip hop, playing music, getting out, playing records, and picking up my camera and taking pictures. Had the opportunity to share some of the photographs in places where some people don't always have access to or may have a hard time getting to. That's both in terms of the places that are around this world and nature, and also some of the places that we're trying to build and the things that we're trying to build with, I'd say, our quantum processors. Well, first, I'd like to say it's an honor to be here on stage with such great peers. This is an amazing set of people that I've had the pleasure of working with. It's been a creative collaboration between these two professionals that I might say are now my friends. And we've been able to make a very special home, a home that I believe to be the future of computing. I've recently returned from multiple weeks on the Navajo Nation, where I enjoyed the practice of introducing oneself by way of our mother's lineage, and then celebrating our homes and sharing kind of a sense of place. So I'd like to talk with you all today about more about creating those senses of places and the homes that we have and the places that we can be creative in. You know, we've brought together kind of our collective superpowers. Heard from Robin and Forrest, and I'm going to give you a little bit of kind of the background of some of the places and things that I've been working on to this point. So this is an image of really one of the first qubits there that's kind of glowing gold. Just above that glowing gold is the actual qubit. So it's something I'd shown in my PhD, a colleague of mine. We were taking a look at these things under the microscope, and I would go to scientific conferences, rooms like these filled with scientists, and people would put up a plot basically of data to show all the great things. And of course, that's wonderful to look at. But if you're trying to talk to anybody else, I was kind of disappointed in not seeing a great picture of the things that people were making, especially what I saw my peers were doing, and no one was actually documenting it very well. So I started to pick up my camera again after I'd been doing that through high school and in college, and encouraged in college to continue my practice of picking up my camera and taking pictures. And this was the perspective that I started to take of, well, not just a microscopic image, but something that could actually evoke question of what it is that you're looking at. Just even simple geometries can be enough to ask a question of what it is that this very powerful quantum processor, and where we're headed from there. I think this may have been the image that got Forrest to join my team. I remember cold calling him with a set of my own portfolio of images of things, and I said, come put art on a quantum computer. And I think Forrest had said, oh, what is a quantum computer? So I had sent him images like this, where these are kind of the beginnings of the systems that we build when we have a big refrigerator that we then start to populate with a bunch of wires and things and these processors. It's just a lovely zoom of another really, a lot of it is geometries, but it's also a couple of qubits here that are coupled, and we were able to show a really important scientific experiment called Bell's violation, where you're actually showing some quantum mechanical behavior that only happens in quantum mechanics. This actually made it into the New York Times, which I was very honored to have the opportunity to shoot one of my colleagues' PhD thesis, where they showed kind of the first time some really important states of quantum mechanics as well, with this modestly sized 4-qubit quantum processor. This was actually my PhD thesis, where I took a picture of the device that I had made in a clean room here at UC Santa Barbara. And in this, I factored 15. So does anybody know what the prime numbers of 15 are? It's 3 and 5. And I had to build a quantum processor that took me about 7 years to demonstrate that we could do that. And then we started to grow in qubits. Here's a whole 5 qubits in a row. This is an image of those devices on a piece of silicon. And then as we moved into the opportunity to work at Google, we started to figure out ways that we could, I would say, start to layer these systems. And you can see here kind of a demonstration of these processors opened up. The idea is at the very bottom is the qubit, there's a wiring, and then this is the combined device. And that kind of beautiful starry night pattern in the middle there is kind of the Oreo filling that allows us to actually marry those two pieces together, both mechanically and electrically. This is an image of the Sycamore quantum processor at Google, where with this modestly sized device that would fit in the palm of your hand, we showed for the first time that this quantum processor could outperform any classical computer, including the largest supercomputer on Earth, on a particular task, which was the first time that anything like that had ever happened. So the thing that we did was complete in about 200 seconds, and it turns out that at that time it would take 10,000 years for a classical computer to do the same. This is what it looks like when you're laying on the ground staring up at one of these quantum computers. I love this perspective, which is an opportunity where you can actually kind of think in your own mind of what it would look like to start wiring up one of these systems. And this is an image of one of those systems basically about to be cooled down and turned on to do computation. Actually, if you hit play on this, you get to observe one of these systems being put together. So there are a number of radiation shields that help block the higher temperature stages. You can see kind of a spaceship mylar there. It's also an infrared radiation shield. That silver can is there for a vacuum. So then we pump this system out and remove all of the air. We put on a big magnetic shield, and of course, we embellish it with a really beautiful painting like what Forrest has done for us of Yosemite there. And so this is now an opportunity to also bring a great friend and colleague into this conversation, James Darling, who's actually here filming today. James and I met back at the university. I think James and I have known each other, I don't know, it's a long time. Maybe we don't say. But over a decade, I feel like, that James has actually been filming and documenting this effort. If you hit play on this one, we get an opportunity to see some of James's work, Robin's work, Forrest's work, my work, and the community here in Santa Barbara who helped us build this space that you've been hearing a lot about. What's lovely to think about here is kind of a superposition of states being, I guess, 2 minutes and 2 years of construction. We were building this space during the pandemic, actually before, during, and a little bit after now. And it's actually set up in a solar day. So you're watching the sun rise and set, and James has actually kind of performed this superposition feat with film here, where all of these things are kind of interstitial at the same time. And you can kind of start to see this become a much more coherent lab than just a big dirt pile and a big blank canvas that Forrest started with earlier. So we have a really a space that I feel like really honors what we're trying to build there. So thank you, Robin, and thank you, Forrest, and thank you, James, for doing a great piece. Yeah, this is an image of one of the pieces that Forrest put up, and then the two of us actually having the pleasure of wrapping one of those quantum computers there with one of his pieces. I might let Forrest tell this story too, but I remember during the pandemic, maybe you all felt this way too, that you kind of leaned on the things like your music, your media, maybe a particular video, but the art that we all loved was the kind of thing that probably kept fueling you day in, day out during the pandemic. For me, I had the pleasure of working as a scientist during the day and then working with Forrest and actually Ando as well in the evening as we painted this huge mural. It was about 100 feet, 130 feet wide by 30 feet tall in this space. So this is just a lovely memory of having art in my life, especially during the pandemic. Go ahead and hit play on this one. This is a fun superposition video that we'd like to share with you all. So I remember when we started this project, we had a couple of ladders and maybe a man lift to try to start painting, which you can kind of see the fun action there. And we realized pretty quickly that that was going to take a long time. And so we kind of, stepped back for a minute and thought about, well, why don't we put up a bunch of scaffolding instead? And that was lovely to get up so that we could actually get up and down that scaffolding. And Ando would pass a bunch of paint, and Forrest would get up there with a big brush, and we'd start putting marks on the wall. It was a lot of fun to have, this big, beautiful mural that we'd seen kind of being designed in sketches, but then to have it project on the wall and then really come to life with all of this color. So this is a really lovely sequence. These are kind of zoom-ins of some of the questions and things that I'd briefed Forrest with. As I said, if you're going to come and put art on a quantum computer, we need to develop a language that helps speak the language of nature. And so you can see some of these ideas here. Maybe you might think of an electron orbiting an atom or whatever may be evoked by that. But really lovely marks. And I love these ideas of having artifacts, found artifacts from the future, in a sense. Just as Les kind of started this off with a great introduction, I think of that being the artifact that I would have brought back from the future. This is great. Yeah, next slide. Next slide. Thank you. This is a wonderful picture of the completed mural. Yep. And the space that you saw a moment earlier where it's actually pretty empty today, it's actually full of quantum computers. And I remember when we were putting these murals up, and a lot of the scientists on my team were kind of scratching their head of like, why are we putting art up in these walls? And now I have folks who come up to me and say, Eric, I think I'm a better person because there's art up in these walls. And we have no problem with people showing up to work. People are actually delighted to show up and be a part of this project. And it's an honor to share this with you all. So thank you.
A couple things. First of all, I don't know if you all noticed, but technically we would call that building that they worked on kind of a garbage building. And normally what people do when they're bringing a new business into a place like that is they blow up the building and start with something else. And so all of these people were very inspired to repurpose that building and make it something beautiful and inspirational. And we thank you for doing that. So now, do you guys have any questions? Yes.
So what got you guys influenced to do space related art and other like space age influenced designs?
It was less about the subject matter. I appreciate the question about what got us into doing space related designs. As an illustrator and as someone who loves to draw, I will draw anything. I'll draw your hat, I'll draw anything. So when I had the opportunity to step up and say, hey, here's an exciting situation to put art in yet a new place, I was like, yeah. So I adapted to the theme and subject matter of space. But to me, I will draw anything all day and stay ahead of the game. So good question, but just stay ready and draw all the time.
What are your guys' favorite parts of what you're doing with this whole project?
Well, that's easy. I'm learning things. And as long as I'm learning something new with a new project, I want to keep going with it. And you can tell this is the world that Eric's investigating is endlessly fascinating. And so it has to do with learning.
My favorite part of this kind of project is stepping out of the thing that I am good at, that I've practiced my whole career on, being an artist, and stepping into a space where that may be unique to bring my skill into, and building a team together of multiple talents and multiple challenges, because that's super fulfilling. It creates a much more rich story than just making art for artists. So I find it really fulfilling.
Thanks for the question. For me, one is the opportunity to work with a varied experts across the field. These are a couple of my closest friends and great, I would say, really amazing people to work with. I also have an entire team back in that lab that I have the pleasure of interacting with every day. And a lot of it is helping to design a space, helping to, I'd say in some sense, design a team, inspire that team, right? To be able to do things that we believe some people might say are impossible, but being able to keep that vision out there and keep inspiring people to do things that will invent the future.
What was the most difficult part of the computer to build?
It's a great question. I would say what you just saw, the space is also a very hard place to build, which we actually have now a big enough space to accommodate the size of quantum computers that we're trying to realize today. A big part of it, I would say, is this. I showed some of the processors as well. Really, there's a whole slew of things that are very challenging. Basically, you're trying to create the most zen place for a quantum processor to reside, cold, quiet, and free from any distraction. And then you're trying to really make all of the materials behave just right. And so we have to do that with a clean room facility, with a lot of material scientists, a lot of engineers, technicians to help us build these things. So it takes an entire team. And if you asked any one of them, they would say, this is probably the hardest thing, right? And so when I think about it, I think it's that entire system. And it's pulling all those things together to make sure that they will all work in concert.
So you guys said that the quantum computers, was it you that said there's 1 billion times stronger than the computers we have now? So like, what is that gonna do for like everyday life, and how is that gonna affect our lives here? I mean, that's a pretty big number.
Yeah, so I'll add some more context and detail. Thank you for the question. I think maybe to ground that idea, what we've shown so far is an important difference between what a quantum computer is and say what a classical computer is. So a classical computer is kind of these supercomputers that we carry in our pocket everywhere. Those are in the same computing class as an abacus. You could use braids if you want to represent zeros and ones, a light switch if you like, a charge on a capacitor. And all of those things are then going to be using what's called Boolean logic to do operations. And all of that is, we've done really well with that. But if you talk about a quantum computer, it's in a completely different class of computers. It uses the laws of quantum mechanics to do computation. And you have these wonderfully new properties that are now at your disposal in computation. I'll just give you one of those, which is this idea of superposition. the idea that the fundamental building block in a classical computer is a bit, but in a quantum computer, it's a quantum bit, or it gets sometimes shortened to qubit. And that qubit can be both 0 and 1 at the same time. Whereas a classical bit like a switch can either be on or off. It's only an or. In quantum computing, it's an and. Now, that's an example of some of the, I would say, richer space that you start to explore. And now, particular problems map really well to a quantum computer. As a scientist, I'm very excited about the fact that it models nature one-to-one. So this idea of quantum simulations actually being able to describe nature one-to-one versus what is a very coarse approximation with a classical computer today. So we showed the actual experiment that we showed in 2019 was a mathematical problem, if you will. It's much more of a benchmark, but it was an important benchmark where we showed in 200 seconds that we could do a computation that would take 10,000 years on a classical computer. So that just if you look at the time differences are many orders of magnitude apart. Now there are the future where we actually have an error-corrected quantum computer. We're not there yet. We have a whole roadmap to build an error-corrected quantum computer. Actually starts to unlock some really wonderful problems, including things I would say associated with climate change. Those are very hard problems, and I want the best tool to help us save those kinds of things. Does that help? Thanks.
I would like to say, hopefully these guys have demonstrated for you how interesting it can be to lead a creative life and to bring creativity to anything that you're doing. And we encourage that.